Okay, so what did we get for problem 7 as our function? So if you're talking about coming up with a sine function, you're basically doing the same thing you did in example 7, which was finding your A, B, C, and D values, right? Okay, so what did we do to find our A value again? Sydney, you okay? No? Tired?
No.
Not feeling well? Yeah? I'm sorry about that. Okay, so what did we do to find that A value for the sine model? So same exact calculation, right, as you saw in example 7. So yeah, your maximum minus the minimum, which would be the depth of 11.3 minus 0.1 multiplied by 1/2. So this calculation would be the same. Anybody who was not able to come up with the sine model for that problem? Okay. Okay, so for the A, 1/2, maximum 11.3 minus the minimum 0.1, and what did that value come out to be? 5.6. Okay. Now, how do we come up with the B value?
The same as the last example where it's like the maximum time.
Yeah, because your period still hasn't changed, right? It's still going to be the same period. Yeah, so since we know that the period for this function is going to be 2 times, what were the times for those values? 10 and 4. Which of course came out to be, let me see, 12. And then what do you do to find the B if the period is 12? Yeah, so the idea is 2 pi over B gives you your period, so that'll be 2 pi over B, which equals 12, and then of course you're multiplying both sides by B, dividing both sides by 12 to get that B by itself. So this will end up giving us 2 pi equals 12B, divide both sides by 12. And what does that period, or sorry, that B value come out to be? Pi over 6, or approximately in decimal. And we'll use the same rounding as the example. So that'll be 0.524. Now, how would we find the C variable? That's the one you're having problem with? Okay.
Find the maximum and then C divided by B equals 4.
Ezra?
Wait, C over B equals 4.
Okay, C over B equals 4. Because C over B is the phase shift, right? And that's where you're getting the 4 from.
That's the maximum depth.
Yeah, and if you talk about the interval, that would be your left endpoint, right? Because our interval, of course, is going from 4 to 10, because at 4 we had the maximum value, and then at 10 hours we had the minimum value, right? Yeah, so you can actually use the phase shift, C over B at 4, and then of course we just calculated b. So what will that c come out to be? I'm trying to think if I want to use the decimal approximation or pi over 6. Probably pi over 6, because otherwise it's going to be a rounded answer to begin with. You're basically multiplying 4 with pi over 6, right? To get c. 2 pi over 3, and the decimal approximation for that? Yeah, and we'll round it to 3 decimal places also. So yeah, 2.094. So what are we noticing from the cosine function to the sine function? The other values were the same, but this guy changed, right? And that's, of course, because your phase shift is going to be different from a sine function to a cosine function. So this value does not come out to be the same. All right, now the last part was finding the d variable. And what are we going to do for that guy? What did we do in example 7? It's actually the similar calculation to what you did A, right? The only difference is you're going to be adding instead of subtracting. Yeah, so you're actually going to be doing 1/2 and then adding the maximum depth with the minimum. Okay. And what does that guy come out to be? It will be 5.7, yeah. So putting all of these A, B, and C values together, what will your sine function look like? Okay, go ahead. 5.6 for the A value. Okay. Okay, so that would be sine of 0.524. And what's our variable here? Yeah, they're actually using t, since t represents the time of the day, right? If you're using x, then just make sure you're defining your x. And go ahead, Adrian. What's after this?
Plus 2.0.
Okay, and why are you doing plus? Remember again, if the number itself is positive, because by default, this is a bx minus c format, right? So you're actually going to leave it as a minus sign. And, oh, I lost my number. There we go. 2.094. And then what do I put at the end? Yeah, plus 5.3. Yeah, you could do that. The only reason we did decimals is because they did decimals in example 7. But I mean, we do have the exact answer. So you could have left this at, so you could have essentially done this guy, 5.6 sine of b, which was pi over 6. T minus c was 2 pi over 3 plus 5.7. Yeah, you could have done that also. So you will have an example, something like this, not with an application, but on your quiz as well.
On the bottom of page 10,
Bottom
it shows
of
the
page
same
10.
equation that we did for where it was 5/6 by 4, or at least the decimal version of it, and they wound up with a different answer, but they did the same thing that we did.
Okay, say that one more time, bottom of page 10.
Yeah, it says which means C equals approximately 4 by 0.524 equals 2.096.
Uh-huh.
But we did that same thing and we got 2.094.
094. Okay, so
Do you think it's because they did the decimal form instead of the...
that's what I'm thinking, because it looks like it's a rounding. So let me see, if we did 4 multiplied by, what did we round it to? Same thing? 0.524. Yeah, you are getting 2.096. So I think it's because they use the decimal approximation. And now, I'm actually kind of surprised they did that, and probably because they kept all their answers in decimals. But usually the practice is, remember, you don't round it till the very last step. So we don't usually round our answers in the intermediate step. But if you did use, instead of pi over 6, 0.524, then yes, your C value will come out to be 0.096. So I guess that could be the basic difference in your calculation.
So then does that mean that they're the same?
So it looks like you actually got A, B, C, and D all as the same values then, didn't we?
Mm-hmm.
With the difference of that decimal approximation, yeah.
That's weird.
That is weird. But you know, the beauty of this example, and the reason I include this example is, you can see for that same exact application, we are actually able to apply both cosine and sine functions, and we will still be able to get our results. So, you know, the questions they were asking you in this example, like, you know, find the depths at 9 a.m. and 3 p.m., you can do those same calculations with the sine function now. The next question was, you know, during what times can they safely dock their boats? So you don't have to be dependent on what kind of function you have to use. So in this case, you can go with either one of them and you will still be able to get those approximations. Okay, guys, so we need to make a correction in example 7 here that we looked at today earlier in our class. So let me go back to what we had done in class and show you where the correction needs to be made. So this is example 7 from section 1.5 that we looked at. And this is where the error happened when we were trying to calculate what our C variable should be, and we ended up doing C over B equals 4, like we had seen in example 7 when they were talking about the cosine function. But unfortunately, we cannot use the same method to calculate the value of C for the sine function. So this part is actually incorrect, which means that the model for our sine function will also be incorrect. So this is what we need to do when we are trying to calculate the C value for our sine model. Okay. All right, so we know that our sine function will achieve its first maximum value at pi halves, right? If you go look at the sine function, we know the first maximum value happens at pi over 2. So that means for our model where t equals 4 a.m., and let's go back to our example here, where t equals 4 a.m. is where our maximum value happens at a depth of 11.3 feet. So we know t has to be 4. So that means when we are calculating our C value, we have to take into consideration the B of t minus C. Now again, like I said, the sine function will have its maximum value happening at pi halves. And in this case, we know for our example, the maximum value happens when time equals 4 a.m. So that means t equals 4. Using that, if we plug these values into our equation here, from the previous step, we know our B value is approximately 0.5 0.524. So we'll go ahead and substitute that in for B, 0.524. We know our t value is at 4 a.m., which equals 4, minus c equals pi half. So we actually have to use this equation to help us come up with the value for c. And if you multiply your 0.524 with 4, that value will come out to be 2.096 minus c equals pi half. So now to calculate c, we can go ahead and add c to the other side and then subtract pi halves and bring it over to the left hand side, and this will end up giving us 2.096 minus pi halves equals c. So we're basically moving our c and pi halves in that equation. And then basically if you can just plug these values into your calculator, you will get an approximate value for c as 0.525. And this is what we are going to need to use to complete our equation. So the equation at this point will then end up becoming, so this will be our sine model, y equals, again, our a value is 5.6, so that will be 5.6, and this will be times the sine function. Our b value, again, is 0.524, multiplied by our variable t, minus our c value that we just calculated is 0.525. And then our d value was positive 5.7. So y equals 5.6 times sine 0.524t minus 0.525 plus 5.7. This will be the sine model for our example. So I hope this shows you what we needed to do to find c, and how this method here ended up actually being the incorrect method, because this was for the cosine function, and of course for the sine function we have to use this idea of where does the sine function have its maximum value, which, as we know from the sine and cosine functions, they do not have the maximum values at the same point. So that's why this calculation needed to be different for the sine function. So I hope this helps you guys out. All right, take care.